And so now let's see the difference between runoff river and pumped storage system. So runoff river, as its name indicates, this one is the river, right? Runoff river, runoff. What we do is like we try to create a wave here, and the water comes through this, and here we have the turbine, and here we have the transformer. This transformer, we will have the generator, so when the water hits the turbine, it will start this one, and then it will go to the transmission tower into the place that we want. This thing, we call it run-off river hydropower. Just like simply a river running and it hits the turbine, so it can give you power. The second one is pumped storage system. This one is a little bit different. I will show you what's really the difference between these two things. So here's the concept of the pumped storage system. We have the first concept is to generate electricity. The second one is to recharge the system. So this is the same. Here we generate electricity, but there is no recharge system here. There is no recharging. But here we can recharge. Let's see. The first one, step one is water released downhill to lower reservoir. This one is upper reservoir. We have lower reservoir, right? So the water flows here down. It goes like this. So on the way, it will hit the impellers in this turbine, and it will on this generator, right? So we have the powerhouse and we have transmission lines. So the water will go here, lower reservoir, right? At the same time, don't forget there's evaporation here. Through time, it's container, so it will evaporate through time. So first release it down into lower reservoir, then water spins turbine to generate electricity. We've said about this. Power added to create when energy demand is high. Okay, so let's go to the recharge system. Let's say there is no enough water here, but here there is enough water in the lower reservoir. So we need to take this water here, so we can release it the same thing. It will power our turbine and our generator. So what we do is recharge the system. Power taken from grid. We take power from the grid when energy demand is low, right? So turbine uses to pump water from lower reservoir up here, right? From this, it will start to pump. So water refills upper reservoir. Gamma point, so it will pump this one and it will fill. So later, when there is high energy demand, we can use this energy source that we get. So things to consider. The first one is water is needed to fill reservoirs from local water sources. This one. This is the main thing that I want you to focus. Evaporation. As I said before, there's evaporation here. So evaporation from reservoirs will need to be replaced each year. When we recycle this water, there's evaporation, right? It will evaporate to the air. So we need to make sure, we need to measure the level, and we need to fill the reservoir, both the upper and the lower. I just want you to focus on these two things. I think the other you can read it. So this is the difference between runoff and pumped. In runoff, there is no recharge system, but in pumped storage, there is recharge. So no recharge system, there is no recharge system, but here we have recharge system. I think it's clear, right? Okay, so let's talk about these things. Factors affecting hydroelectric power output. So there are several factors influence the output of hydroelectric power plant. Mainly, the first one is water flow rate, the second one is reservoir level, and the efficiency of the turbine and generator. Here we have the water flow rate. Water flow rate. The volume of water flowing through the turbine directly affects the power output. Here we have, as I said before, here we have the turbine, right? Here we have the turbine, right? Here. So if this amount of water is, you can see the gap or the distance from this to this, let's say small, and if there's high amount of water, there's gonna be high pressure here, which is really neat because it can speed up the turbine. So the water flow rate directly affects the efficiency of the hydroelectric power output. We can say the volume of water flowing through the turbine directly affects the power output, the volume. If there is high volume in a small area, in a small diameter of pipe, there's gonna be high pressure, so it's gonna increase the speed of the turbine. So when the turbine is rotating at high speed, it's gonna generate as more kilowatt, in which that pass through the generator. So we can say this one is the water flow. The second one is reservoir level. The height of the water in the reservoir determines the amount of potential energy available. Lower reservoir level results in less potential energy, leading to decreased power output. This one is also obvious. This one, as you can see here, we have potential energy, right? And the same thing here, we have this energy. As it goes like this, it is going to convert into kinetic energy. So if this one is higher, there's going to be high potential energy, which means there is high power output. But if this reservoir is at lower position, this means that we're going to have lower power output. So the reservoir level also affects the efficiency of the hydropower. The first one was water flow rate, then reservoir level, then turbine efficiency. The design and condition of the turbine influence its ability to convert kinetic energy into mechanical energy. Higher turbine efficiency leads to greater power. This is obvious. We have different kinds of turbines, but for this one, as you can see, there's potential energy here. As it starts flowing, this is going to convert into kinetic energy, right? So here, the turbine is going to convert this kinetic energy into electrical energy, right? So if the design of the turbine is correct, by all means, we're going to get higher power output. So it should be efficient enough to generate the power that we need. The last one, the same thing, generator efficiency. This one is also the generator's ability to convert mechanical energy into electrical energy affects the overall efficiency of the plant. Higher generator efficiency results greater power output. So if you get my point, we have four things that affect hydroelectric power output. The first one is water flow rate, right? There should be higher volume of water, especially in a small area. And the second one is the reservoir level. Higher reservoir level means there is higher potential energy, so we're going to get higher power output. The same thing, if the height of the reservoir is at a lower level, it's going to be small power output. And then we have turbine efficiency. Here, the same thing for turbine and for generator, they should be efficient enough to give us the power that we need. So this is all about the hydroelectric power. I think